and we have to return the total amount of water trapped within those walls. Am I understood the problem correctly?
Yes, you understood the problem correctly. The array elements represent the height of walls side by side, each with a width of 1 unit, and you need to return how much water can be trapped between those walls after it rains. Can you clarify what the output should look like for a valid input? What type of value will you return?
Okay, let's take an example of 420325. This is my input array. I hope you got the input.
Yes, I got the input array with heights 4, 2, 0, 3, 2, and 5. For
Correct.
this input, what do you
Correct. So I'll go with like this, calculating each permutation and combinations of contiguous array of 0, 1 or 4, 2, 4, 0, 4, 3, 4, 2 and 4, 5. This is how I gradually start. Then I will go 2 to 0, 2 to 3, 2 to 2, 2 to 5, and I will calculate in between the width and the length, a total minimum length of height in between left and right. So that's how the brute force approach will work.
Thanks for explaining your approach. So, you were thinking of checking pairs of walls and calculating trapped water based on the minimum height boundary between them. That
Right.
part sounds like a reasonable start. Can you describe how you might improve the efficiency of this approach? What challenges
Yes.
do you see with
Yes.
That is a good improvement from the brute force approach to using prefix and suffix arrays to record left max and right max heights. Your explanation suggests you understand how to reduce the time complexity to linear time while using extra space for those arrays. Now that your approach is clear, would you like to go ahead and implement your solution in code?
Because that's the greater one, right? So that we have to subtract it from height of left. Okay.
I see you are carefully comparing the current height at the left pointer with the left max and either updating the left max or adding trapped water by subtracting the current height from the left max. That's on the right track. Can you continue your implementation by describing what you will do on the right side when the height at the right pointer is less than or equal to the height at the left pointer?
Yeah. So I got completed the left part. Let me write the right part as well. So if height of left is greater than equals to the right part, right max, so that means we have to update our answer or the right max thing, that our hypothetical wall. So right max, which will be equals to height of right. Otherwise otherwise we have to calculate the total water that can be trapped. So we will have plus equals to height of right. Okay, and after that we will do right minus minus, because we have to shrink it as well from the right. Okay, so I think let me submit the code.
Thanks for sharing your code. Could you check where your logic might be going wrong by tracing the code for a test input where the trapped water is not coming out correctly? For example, what does your code return for the input where heights are 4, 2, 0, 3, 2, 5? Where do you think it breaks?
um, Let me rephrase the problem again. um, Let me dry run through my approach and code, and once I do that, I will come back to you again. Okay.
That sounds like a good idea. Take your time to dry run the code and review the logic carefully. When you're ready, feel free to share your observations or any part you want to discuss further.
Okay, so we are at the left pointer is at 4. We will check if this 4 is greater than the left max. If height of left is actually greater than the left max, we'll uh, update the left max, right? So before that, I think we have to do one thing, like we have to update whatever the max in between it, right? So max of mat dot max of this thing, height of left, as well as the current left max. So similarly we will do in this as well. So mat dot max, we have height of right comma right max. I think that's the case I was missing initially. I think I corrected it.
I see you updated the code to use max when updating left max and right max. That's a useful correction. Looking back at your code, do you notice any issues with the way trapped water is added to total wa in the right pointer part? What should that calculation be instead?
Um, so we have total water initially as 0. So we are at 4 and we don't have a left max. So we will update it left max as 4 and we will move forward towards 2. So at 2, uh, position 2, we will have a current length as 2, which is actually smaller than the current left max. So we will simply add total water equals to 4 minus 2, that is left max minus height of left. So that will be 2 as of now. After that we will go to the left, again to the right, left pointer to the right. I think my solution is correct, and it will give us as of now I calculated 2 and 4 to 1, and again 1 and 2, so 6 7 8 9. So this, the input approach or the input size we take, or input scenario we take, it will give us a 9 as of say. It will give us an answer total amount of water that can be tapped within this input, that is 9. And I think my answer is correct.
It sounds like your reasoning about how the trapped water is calculated is solid, especially with the left max and the differences. Now, looking at your code, can you check if your implementation similarly handles the right side correctly in terms of adding trapped water?
Yeah,
Do you
yeah,
see if the calculation?
that's the case I missed, and I updated that in the right. Previously I was doing like total water is I was not subtracting it from the right max. That I have corrected it. I corrected my mistake properly. Now it is correct, being corrected, calculated.
That's good to hear you spotted and fixed that part where you needed to subtract from right max when accumulating trapped water on the right side. Now that your code logic looks correct, would you like to walk me through the time complexity of your solution?
Uh, yes. The time complexity, it will take order of n, because we are not iterating and iterating. We are shrinking our window size, the 2 pointers. So it will lead us to n by 2, because we are moving one pointer at a time. But neglecting the constants, we will be considering as um, order of n. The time complexity will be order of n, and the space complexity will be order of 1, as we are not using any extra space.
Exactly, your analysis is correct. Since you move the 2 pointers inward each time without nested loops, the time grows linearly with the input size. And because you use only a few variables and no extra arrays, the space stays constant. Do you think this approach is the most efficient one possible for the problem given the constraints?
I think yes. I've already told the brute force that goes up to n square, possibly calculating all the permutation and combinations of sub arrays, which will cost us n square. After that, I've give a better approach that is cost us a big order of n time complexity and order of n space complexity, calculating the prefix left max and the suffix right max. And this is the most optimal approach I can think of as of right now. And I think this is the rightmost approach to solve this problem with the two pointers and as compared to the other ones. Yeah, that's it.